Alright, now it's up and running, hopefully. Let me check what's going on. Okay. Alright, I think it works now. Let me check the sound. Okay, perfect. Now let's turn on the music and let's go. Okay, I think we're good. So yeah, last time I mentioned that I found a couple of bugs and I was fixing them and we will walk through all of them. First things first, the one that I mentioned is that rocket is not flying correctly, like it starts to fly in weird directions. I fixed that, and yeah, I was right, the problem was with recoil. I did some testing, and yeah, even if I bring recoil back, it still works fine, so it still flies forward. It flies exactly where I aim, and recoil is being applied after that. So my assumption that it was related to recoil was correct, and surprisingly that was the easiest bug to fix among all others. So here I was rotating an actor, but that was incorrect. Instead, I should rotate the mesh of an actor. So for y-axis I'm rotating the mesh, and for x-axis I'm just rotating camera. So, and see how I split it, because that makes sense. So recoil is the property of the gun, okay? And different guns produce different recoil in terms of direction. So because all like weapons have different weight, different size, and the direction of recoil, vector of recoil, is essentially property of the gun. So that's why apply recoil function stays, and this function is supposed to compute the recoil vector. Here particularly we don't compute the vector, we compute deviation angle for x and y. I mean deviation angle around x and y axis, and we pass it to the person, because person, the actor in this case, he's the one who responds to that recoil in certain way, and it totally makes sense. The only thing, I check if our actor is capable to handle recoil, because if not, we will not compute the recoil vector and save some CPU cycles. So, but if actor can process recoil, we compute deviation angles and pass it to the actor handler. And here in player, let me open this. Yeah, we just implemented this function. We receiving x and y deviations, and yeah, for y we rotate the mesh, and for x we just rotate camera. It's essentially the same thing where we process pointer input, right? When we move our mouse, for y-axis we rotate the character, and for x-axis we just rotate camera. It's just we're looking up and down, and yeah, we clumped our value here, and so we must do the same here. And actually it's a good opportunity to lock these values. I can actually maybe even do here so this look up and actually let's keep it separated. Yeah, why not? Look. Actually, I'm not sure what is up and what is down here, but let's see. I think when we look up, it's a negative thing. Here's a positive thing. I think. So let's just do this. Okay. So we have our limit, and same for recoil, cannot rotate us too far. Okay, that was the problem number one. Problem number two. Problem number two was related with explosions. So essentially what was the problem is that here we were casting rays from origin to the target without distance limitations, which means that even if our target behind explosion sphere, I mean outside of explosion sphere, and should not have any damage of explosion, it still will be hit by a ray, which means that this condition will pass. And yeah, computed damage will be 0 essentially, but it still will be put into the stack and monster will be triggered. Let me maybe show what was the problem with the bug. So explosion here, and here we have two sectors, here and here, which means that collisions with these guys and these guys should be checked at least. And yeah, they would be outside of explosion sphere. They will not have any damage, but because they were hit by ray, they will be triggered. So practically this condition will pass, and it puts the damage to the damage stack, and all those monsters will receive 0 amount of damage, but that damage will be processed, which means that they will be triggered, because when we put when we put the damage infliction on the stack, we pass the after of the damage, and actually each projectile has its after, right? So we have these indexes 1 and 0, and yeah, those are our arcs essentially. Yeah, source explosion. Okay, it's we add here, but yeah, here we push to the damage stack, and in our arcs we have an actor. We have like an entity that caused that damage, and it goes to the damage stack, and even if actual damage is 0, those monsters will perceive it as if they were hit by me, which means that they should become angry at me, even if they had 0 damage, 0 actual damage. So I needed to fix that, and I actually fixed that quite easy by adding distance limitation to that function. So essentially it's new parameter, it's explosion radius. So, and now all the trays, they don't go further than explosion radius, and they never check collisions outside. So yeah, I practically put this thing into here, into separate variable, and just passed it here. So let me show you how I refactored that function. Because yeah, I actually changed few of things. Maybe let me open the actual code, clean code, where it was. Probably close it. Okay, not a problem. Here. Okay. So here is new parameter, distance, and look how we approach it now. So first we compute direction to the target, right? Then we compute like normalized direction, which is unit vector towards direction, right? And now here, so full distance is either distance that we pass or the full distance between current origin and target position. And yeah, actually, current origin, this is, I start measuring the distance from the actual array origin. You remember we have this offset property, so we want to cast our array outside of the mesh that emitting the ray, so we exclude self-collision, right? So here we practically put the radius of the monster, let's say, which means that the ray cast will start outside of the monster. So, and actual origin of the ray, it's not the origin of the monster. So practically we move our origin of the ray a bit further along the direction to the target. So we start to cast our ray outside of the monster or any other entity. And our full distance, it's actually the distance not between monster origin and target, but between ray spawn point and the target. That's our full distance. However, this distance can be less than that if it's provided as parameter. And in this case, remaining distance is a full distance, and later, if we will have unwanted intersection, we can do a second ray cast. But the thing is, now when the ray is short, it never really hit any entities outside of explosion sphere in this case, right? If we call this function when we calculate explosion. So yeah, we gather all our targets within current sector and neighboring sectors. We try to cast rays towards them, but if we're too far, the ray will not reach them and the hit will not be registered, which means that condition here where is it? Yeah, which means that this condition will not pass. Actually, even this will not pass. We will not have picked mesh, so we will not even have a hit. So practically there will be no hit, and it will not go any further. Which means that we will not pass this damage to the damage stack, and monsters will not be triggered on me because I didn't hit them. This change enables another interesting thing, is that now we can make our monsters blind at certain distances. And let's actually experiment with that. I think it's quite easy. If we go to our monster class, right? Okay, we have to like for target. Okay, here I pass now, so now monsters can see us from wherever they want, but if I keep it like 10, they should not be able to see. So I will try to pass it really far. And see, it doesn't react to us like at all. Because we're too far and it cannot see that far. If I go closer, okay, something strange happening. Okay, maybe let's set up. Let's do 50. I think that's reasonable. Cannot see, but if we're too close, it's trying to approach, but if we run too far, it cannot see us anymore, and it's just chasing the last direction that it remember, but if it will be too close, it should, yeah, churn, yeah. Well, actually it works exactly as expected. The only thing we need to choose this value wisely. So it still should be quite big, so it looks like adequate, but monster is always following us when he is at a reasonable distance. But for simplicity I will just keep now, it's fine. So now it always can see us as long as we are inside the view angle. Yeah, that's interesting change, and the reason behind it was the fact that I wanted to fix explosions. I didn't want monsters to be triggered if the explosion actually didn't damage them. And yeah, I introduced this ray length limit. So, and for explosions, this is explosion radius, so those rays never go outside of the explosion sphere. And as a side effect, yeah, now we can limit how far monsters can see. Okay, that was the second thing that I fixed. There was something else. Oh yes, that thing. So, what was the problem? You see, if I shoot and if I destroy the glass, so there is no more glass and rocket should go through. But in fact, before, even if glass is destroyed, it still collided with its location and rocket exploded midair. So we didn't dispose the destroyed glass properly, and this problem actually much deeper than you may think. Because look, here, yeah, I added this thing and I explained later, but how it was. We dispose physics body, we dispose physics aggregate, we dispose bounding box, we dispose mesh, and it feels like those things should be removed from the world, but that's not true. Yeah, it's removed from Babylon scene, but because they were assigned to the static grid, here, yeah, by this function they just got inserted into the static grid, and references to that meshes are still alive. They are not deleted by garbage collector, and that's why when we call test function, yeah, test position, when we call this thing, yeah, this function returns false positive, because inside our static grid the mesh reference is still there, and apparently call of this function still works as if it's there. So why we didn't notice this earlier for regular bullets? Because regular bullets, they rely on physical aggregate, and physical aggregate being disposed in the glass. So once we call this, okay, there are no more physics bodies and bullets can go through, but for rockets, which are not physical, essentially, they just move forward, we compute mesh intersection, and because the link in the static grid is alive, that intersection check function returns a positive result. So the solution is just to remove it from the static grid. So practically what we do, our static entities, which might be walls, which might be huge planes of glass, they may go through multiple sectors, not just neighboring sectors, but from multiple, right? So what we need to do, we need to get all sectors that are affected and pretty much manually clean those. That's procedure quite expensive because, yeah, if we have long glass, we need to go through all those sectors, go through all arrays and splice them. But because a static grid is intended for static nodes that usually do not change often, it's okay. That function will be called really, really rare. And yeah, once we removed those glass references from the static grid, everything works. Then you probably may have questions about it. Let me remind you, for our sector management, we have two types of grids, right? We have static grid and dynamic grids. Dynamic grid is intended for entities that change their position often, that may appear, disappear, and move fast. Practically, it's monsters, it's some physical meshes like crates that we can push between sectors. And for dynamic grid, we are not using arrays. For dynamic grid, we use linked list, like two-sided linked list. And when we want to remove something from the dynamic grid, we just remove entity from the linked list, which is all one operation. We don't really need to go through multiple sector and splice and shift arrays. Why it's possible? You may have question, why not to do linked list for static grid as well? So let me explain. Entities in dynamic grid are always much less than a sector, even much less than half of a sector, which means that a dynamic entity like a monster, it cannot really present in more sectors than just neighboring sectors. So in fact, dynamic entity, it's always assigned only to one sector, only to one, but our test functions, it checks current sectors and neighboring sectors. So we detect current sector of entity, we check current sector, and we check all sectors around it in case if our entity is on the edge. But because entity size is small, it cannot go further than current sector and maybe partially nearby sector. But for static nodes, what are static nodes? Static nodes are walls, like planes of glass, and some other large things that can span across multiple sectors. They can be like easily like 10 sectors in the row, right? So in this case, we cannot assign them just to one sector and check this sector and all neighboring. So here we actually need to assign them to multiple sectors, and this is what we do. So where at static nodes we get this get affected sectors, and we actually push our thing. I call it like monster blocker, which is true way block monsters. We push this entity to every sector that it intersects. But for dynamic entities, we only assign it to the one sector. That's why for dynamic grid we can use linked list to remove thing, and for static grid not really, because we need to clean it from multiple sectors. Yet technically inside each sector we potentially could do linked lists as well, but I decided not to make things more complicated here, because I repeat, static nodes unlikely to disappear or move, or at least it should not happen as often as dynamic entities. So that's why I think it's quite okay to clean it manually. Yes, it's, I guess, ON operation here, because we need, it's actually O2N operation, because first we need to find entity, right, with index of, and then we need to splice array, which is in our ON operation. But that's okay, because this happens really rare. And for dynamic entities it happens like all the time, because we're always moving and we need to like move from sector to sector. That's why here we use double linked list and essentially O1 operation. Yeah, quite annoying thing is that reference to object is alive. You know what could help? For maps and for sets, there are like types which is called weak map and weak set. So if we use weak map or weak set, then if we like dispose entity, the weak map or weak set doesn't hold it, so it would be removed automatically. But since we use array, it's not happening, and array actually holds the reference. So maybe if weak array exists, maybe it could work, or we could maybe change it. Instead of array, use set, for example, but set doesn't really keep the order of things, and for debugging purposes, I prefer to have order. So good enough. Okay, so we will not redo sectors manager, we just practically needed to add helper function to remove the entity from all sectors it spans across in case if entity got removed. And yeah, it fixes the bug for rockets because yeah, once class is destroyed, all references in the sectors got killed and rocket can go through. Okay, this is problem number 3. Problem number 4. Its pickup sound of the medkits was way too low. And let me explain why the hell this happens. Look how we initialize sounds for weapons. They got attached to picked mesh, and picked mesh, it's the mesh that we hold in our hands. So what it means on practice: when we pick up something, all sounds attached to the mesh, to the gun that we're holding in the arms, and apparently it also applies to the pickup sounds. The source of the sound is not happening from the weapon on the ground, the source is still our hands. That's why it sounds quite loud. Yeah, we like run this function, initialize sounds, and they all got attached to where the gun is in the arms. That's why even pickup sounds, it's happening very close to ears and it's loud. But that's not true for medkits. We don't do that. We execute sound where the instance on the floor is, and to compensate that, I just increased volume and that's it. So right now, pickup volume is like more consistent with other things. It sounds like around the same, right? Before it was super low. And also I adjusted volume of this. Here I can come like really close to the medkit, that's why the source of sound is much closer, but still I needed to balance it a little bit. So for object on the floor I multiply by 7, and for floating object I multiply just by 2. Yeah, hope it fixes that. And last thing, I decided to update to Babylon.js 9, because the difference between this version and this version is that they just dumped documentation, and I thought it's pretty safe to switch right now. However, 9.1 and all other versions that follows, now 9.3.2 is available, I believe. They did a lot of changes there, and I don't want to rush with those, because this is where actual transition happens, starting 9.1. So I maybe switch to those later when I investigate it more, but just switching to 9.3 0, 0 is okay because nothing changed pretty much as I understand, except documentation between these two. So I will keep it as is, and let's review our code just in case. So maybe I forgot something. Okay, we explained this. Okay, like limits, recoil, helpers, yeah, line of sight, function is refactored, added distance limit, and yeah, fixed stuff. Here, yeah, like we just pass this limit. I also deleted old guns that we didn't use anymore. For monsters, yeah, we added new parameter for distance, but I decided to keep infinite sight for monsters, so they can see you from anywhere as long as you are in the line of sight. Distance doesn't matter, but it can be easily tweaked for balance if you wish, but for now I will keep like that, so monsters always can see you on unlimited distance if they look at you. If there is no obstacle between their eyes and you, then they can see you. So here, yeah, I dropped a couple extra rockets to tests, but now they are not needed anymore. Okay, here pickable object, floating object, just tuned volume, and here, yeah, call this function that removes it from the sector manager. Well, as you can see, right now the version that is in prod at Babylon.js at Babylon.js-fps.com, my prod version, it's really buggy, so those things that we addressed here should be uploaded. I will do some additional tests after that behind the scene, but I will try to deploy it before next weekend. Let's fill the commit message. So what else we did? Fixed. Right, so line of sight. Will remove static nodes from sector manager. And that's the thing. This is our patch. Okay, good. It was deep investigation, but we addressed a lot of stuff. And so for now, what comes next? I will do some additional checks and try to deploy it before next weekend. But next weekend, I have to say, we will not meet. I will skip stream on next weekend. I have something to do, and genuinely, I really want to have some rest because I'm super busy at work, and addressing these issues that we discussed today, it really took me half of Saturday. Well, not a half, but maybe like 3 hours or so. And I already worked hard the whole week before that. It's busy week, and yeah, also I needed sort of work on this one on Saturday. Yeah, I'm super tired, and next week also expects to be quite hard. So yeah, I just want some remaining free time. But still, even if I skip stream next week, again, I will investigate this stuff and see if everything is okay, and if so, I will deploy it before next weekend. So if this all looks okay, you may expect that at least there will be new version deployed to the website. If I find something, I think even if I find something, I will just fix and deploy. It's fine. So yeah, you will not be able to see me next week, but at least you can go and check what I deployed. I don't know which day I will do that, but I will try. So with that being said, I'll see you in 2 weeks, and have a great upcoming week. Thank you everyone who's watching this, who's following. I really appreciate that. Alright, see you in 2 weeks. Bye.